Imagine a scenario in the future in which we have finally solved the greatest mystery of all: are we the only ones? The possibility of another civilization in a universe with countless stars and galaxies is both exciting and terrifying. Today, we take you on a journey of revolutionary discovery that may alter our understanding of universe-wide life. A wave of curiosity and excitement has been sparked by an unprecedented discovery made by the James Webb Space Telescope 7 trillion miles from Earth. What if we weren't the only ones? I think the Milky Way might be home to a civilization right now. It's unbelievable. I gasp. Over the next 10 years, we will gain a lot of knowledge. The James Webb Space Telescope has made an unprecedented discovery: city lights in space, 7 trillion miles away from Earth. This exceptional disclosure has caused areas of strength for and of interest in the chance of extraterrestrial life. The telescope zeroed in on Proxima Centauri b, the nearest exoplanet to Earth, and uncovered uncommon light exuding from it. On Proxima Centauri b, what could be causing these city lights? Could this indicate that life exists beyond our own planet? Let's look at how these strange space objects were found by the James Webb Space Telescope. The James Webb Space Telescope's discovery of city lights on Proxima Centauri b could be the first concrete proof of extraterrestrial civilizations. To gain a deeper understanding of life beyond our solar system, researchers and the general public have been working on it for a long time. Over the course of time, any evidence that is thought to support this space fantasy has been welcomed with joy. The James Webb Space Telescope's recent discovery of strong evidence of life in space caused a shock to the scientific community. While investigating space and communicating significant data to Earth, the James Webb Space Telescope saw abnormal city lights sparkling from the exoplanet Proxima Centauri b. As the name recommends, the city lights appear to enlighten a far-off city. Scientists have been taken aback by the possibility of an alien city in our star system. Because it appears to be the existence they have all been anticipating, each of them is perplexed. Everyone thinks that if it turns out to be true, it means that intelligent life forms are organizing civilizations far from where we know humans to be in space, and we are only just learning about it. Our understanding of the cosmos and our place in it could be fundamentally altered if the existence of an extraterrestrial city on Proxima Centauri b is confirmed. NASA engineers can't help but wonder how long these cities' lights have been shining in space, waiting for humans to develop the technology necessary to detect them, as they look at them 7 trillion miles away from Earth. David Kipping, a space expert at Columbia College, portrayed the exoplanet Proxima Centauri b, where the city lights were spotted, as a test. He claimed that this is because, in contrast to other planets, the star system closest to us has distinct heating patterns. This exoplanet's infrared nature is quite distinct from that of its host star Proxima Centauri, which is known to absorb sunlight and emit infrared radiation. However, this is not the case with this exoplanet. This permits the James Webb Space Telescope, JWST, to mention great objective facts, and the telescope has shown to be an optimal device to get everything taken care of. The heat signature of Proxima Centauri b, which can be easily detected by JWST, will be crucial to figuring out more about the planet's atmosphere. Could the advanced infrared capabilities of JWST shed additional light on the atmosphere and potential for life on Proxima Centauri b? The most recent infrared imaging technology used by JWST would have led to this. The telescope will be used by scientists to look into the mysteries of the planet's atmosphere and conditions. Additionally, they intend to test the exoplanet's habitability with the Webb Telescope.
Delta rocket carrying
The
GLASS,
James Webb
a
Space
gamma-ray
Telescope has the infrared
searching for
sensitivity
unseen
necessary
physics
to
in the
investigate
stars of the
Proxima
galaxy.
Centauri b's nighttime activities. Space telescopes typically face difficulties in capturing even the faintest rays of light in the cosmos, but JWST is capable of doing so from space. It is the ideal instrument for determining whether or not the dark side of Proxima Centauri b has city lights. A telescope can pick up any artificial light in the universe as long as it has a frequency band 1,000 times narrower than starlight. The first concrete proof of extraterrestrial civilizations could come from JWST's ability to detect faint artificial light in space. How does the planet Earth compare to Proxima Centauri b? Surface interactions and stellar properties are interestingly linked in Proxima Centauri b. The exoplanet's day side contains various sunlight-based chargers that outfit the foaming radiation energy that the star has. The unearthly edge likewise mirrors light beams from the ink. As Proxima Centauri b completes its orbit around its host star, Proxima Centauri, it experiences day-night phases similar to our own on Earth, with warm, solar-rich days and cool nights. The planet is known to have not entirely settled by its creation. On Proxima Centauri b, for instance, there would be a significant and evenly spaced difference between its day and night cycles if there were no atmosphere there. The day side would be as hot as a black body without the ocean and atmosphere, while the night side would plunge into a terrifyingly cold darkness. Astronomers can gain a better understanding of the atmospheric composition of Proxima Centauri b by studying the magnitude of the temperature variation. Could Proxima Centauri b's unique temperature fluctuations and atmospheric composition be the key to understanding its habitability? JWST is able to effectively examine the planet's thermal emissions and provide pertinent information on its atmospheric properties thanks to its unparalleled infrared imaging capabilities. Interestingly, the JWST's orbit around the Earth coincides with Proxima Centauri b's, making it possible to observe the planet's day and night cycles for 11 Earth days. Since Proxima Centauri b has an environment, the subsequent stage will be to survey the science of its air to decide if it could uphold life. The presence of gases like methane, oxygen, and water vapor is a good sign that there is life on the planet. The planet's support of habitable conditions indicates that these elements can be found there. Scientists must be careful enough to capture and examine light rays passing through the planet's atmosphere in order to make a successful conclusion. Even though JWST has excellent capabilities for describing planetary atmospheres, this is a very difficult task. The first step toward establishing whether or not Proxima Centauri b is habitable might be the discovery of important gases in its atmosphere. JWST has a secondary objective. Changes in the concentrations of methane, carbon dioxide, and water vapor will be studied with the telescope. JWST is only limited in this area when it comes to determining the amount of bound oxygen, a crucial indicator of life. Nevertheless, telescopes have valid reasons to search the planet for additional features. Ozone, which is what gives the atmosphere its precise energy levels, is one of these reasons. In addition, it is important to note that the James Webb Space Telescope is not all-powerful and can only observe some of the habitable worlds closest to Earth for in-depth atmospheric research. Gr.